Okay, there is a little bit to write down here first, which is kind of why I'm worried I won't get to much before everybody leaves. But we're talking about optimization problems. Optimization problems. Sounds kind of fancy there too. And I want to just explain, first of all, what optimization is really talking about. I mean, if you think about the word optimize, what you're doing when you try to optimize something, it says to optimize a situation means to find the best possible solution. And you can think about this in several different scenarios. I mean, you don't have to list all these in your notes if you don't want to, but thinking about some things that you might want to optimize, you might want to maximize the volume of something. Or if you're running a business, you might need to minimize the cost of something, maximize the area of whatever you're working with. So notice, optimizing doesn't always mean maximum. Like, you're not trying to always get the max of something. You could also be trying to minimize something. So again, this is just kind of in general what optimization is talking about. Okie doke. Now, I'm also going to go through some steps to help you solve some of these optimization problems. And so that's basically what I have up here. Steps for solving max and min optimization problems. Steps for solving max and min optimization problems. And by the way, if you do go to the link later, if you have to leave early and you missed some of it, you can take your notes back out and try to take notes while you're watching the video, just like you would if you were in the classroom doing it. That's actually how my students had to learn a couple years ago when I was on maternity leave. I videoed all my lessons, so they just sat in their seats and watched me teach while I wasn't here and took notes the whole time. So try to kind of do that at home also if you have to do it that way. All right, step one, identify all given quantities. And this is just something you kind of do in your head. Identify all given quantities and all quantities to be determined. Again, this is not really something you have to write out, but it will be important to know what you know and what you don't know, what you're actually trying to find. All right. Now, step two is a good one. This is very important here. This step explains how to set up your equations. There's two equations, primary, secondary. It says write a primary equation for the quantity that is to be maximized or minimized. Again, write a primary equation for the quantity that is to be maximized or minimized. Write a secondary equation based on the other information. And I will label each of those. It is going to be important to know which equation is the primary and which one is the secondary. So that will be important. Okie doke. Couple more steps here. Step three, another good one. Well, they're all good. But step three says solve the secondary equation. Solve the secondary equation for one of the variables. So doesn't matter which one. solve the secondary equation for one of the variables, and substitute that expression into the primary equation. Solve the secondary equation for one of the variables, substitute that expression into the primary equation. And step 4, thank goodness, a little bit shorter down here. Take the derivative and solve. Finally, take the derivative and solve. Okie doke. 2 different equations, primary and secondary. So again, we'll have to take the time to label each one so we know which one to use. Okay, I'll try to get through at least one example here before you guys have to leave, or some of you. Example 1, find 2 positive numbers. Find 2 positive numbers whose sum is 48 and product, or maybe I could say, and whose product is a maximum. Find 2 positive numbers whose sum is 48. Sum means add, don't forget, and whose product is a maximum. Now, just like in any algebra type of problem, this is not going to be algebra here, but I always like to define my variables just so I can start using them. I'm going to say let x equal the first positive number, and then I'll just say let y equal the second positive number. You're not always going to be working with just random numbers. Like here in a little bit, I think we'll get to length and width. So one variable will be length, the other will be width. So that can change. Now, the next thing that I would like to do is I would like to set up my primary equation and my secondary equation. So I'm labeling both. This is basically step 2 that you wrote down earlier. So step 2 said, I'm just rereading it, write a primary equation for the quantity that is to be maximized or minimized. So maybe I could do some color coding here. I'll make that green. This right here is the part that's talking about a maximum. It says the product of those 2 numbers is a maximum. Whichever part talks about the maximum or the minimum, that has to turn into your primary equation. So basically, if I take those numbers, I don't know what they are yet, but one is x and one is y, if I multiply those numbers, their product should be a maximum. I don't know what it is, but I do know it's a maximum. So that seems weird, but we're setting it equal to the word max. Now, secondary equation. Secondary equation just puts together all of your other information. So the other part that was given to you that didn't really have to do with the maximum or the minimum. That part for us is right here. It says that the sum of those 2 numbers is 48. I can actually set it equal to a number this time. The sum is 48. Okay, step 2 is done. We set up both of our equations. Now, step 3 says solve the secondary equation for one of the variables. It does not matter which variable you solve for. Out of habit, for some reason, I always like to solve for y Maybe it's because it kind of reminds me of slope-intercept form, good memories. So I guess that's part of the reason why I always solve for y, but it doesn't matter. Solve the secondary equation for one of the variables. So I did that, and then it says substitute that expression. I'm getting a lot of colors up here. Substitute that expression back into the primary equation. So this is what y equaled. That means I'm going to replace y up there with 48 minus x. So it no longer says x times y. Now it says x times 48 minus x equals a max. I still don't know what the max is, but there we go. Now, before I take the derivative, I'm going to distribute the x. So now it's 48x minus x squared. And we basically have to take the derivative of each part separately. Derivative of 48x is 48. I don't need my equal sign yet, Mrs. Street. Derivative of a negative x squared is a negative 2x. I don't know what the max is, but I know it's a constant. It should just be some number. And what's the derivative of any constant? 0. Now I'm going to solve it for x. So, getting crazy up here with my equal signs today. I'll add 2x to both sides. That's probably the quickest way to do it. Then divide both sides by 2, and I get x equals 24. So the first number is 24, and if you plug that back in to find what y is, it's probably easiest to plug it in right here. 48 minus 24, that's actually going to give you another 24. It's not always going to be the same number, but a lot of times it is. If you're trying to maximize a product, then most of the time you want to use the biggest numbers possible. Okie doke. Free to go if you leave half day. I'm going to keep going, so don't forget to check the website for the YouTube link. I apologize if the video is poor quality. I'm trying to do my best here. All right, assignment is on there too. Now, here you are, clicker. Let's go ahead and try to do another example, or two. We'll see which one has our idea. Example 2. Now it says, find two positive numbers. Find two positive numbers whose product is 72. Whose product is 72. And the sum of the first plus 2 times the second is a minimum. Find two positive numbers whose product is 72 and the sum of the first plus 2 times the second is a minimum. All right. Now, again, this is kind of, I guess, silly to repeat this, but I'll do it again. I'll say let x equal the first positive number, and then y equals the second positive number. The word positive didn't matter to us much on the last example, but it does come into play sometimes if you get back a plus or minus somewhere, then you know that you only want to keep the positive. All right, primary equation, secondary equation. Remember, the primary equation should always be the part of the problem that talks about the maximum or the minimum. So I'm reading through the problem here, and I see at the very end is where they talk about the minimum. So this part right here, that is going to help us set up our primary equation. So it says the sum of the first plus, so here comes the plus sign, plus 2 times the second. I'm just going to write that as 2y. Whatever that is, it should equal a minimum. So x plus 2y equals a min. What will our secondary equation say? Anybody know?
xy equals 72.
Exactly. xy equals 72. That's the other part of the problem. Doesn't talk about the max or the min. Okay, like I said earlier, it doesn't matter which variable you solve for here. That was weird. It went from red to black. Let's try that again. I usually like to solve it for y. It's just kind of out of habit. So when I do that, it says y equals 72 divided by x. That is what I need to plug back in to my primary equation. So wherever I see y up there, I'm replacing it with 72 over x. Now it says x plus 2 times 72 over x equals a minimum. All right. Well, I really need to simplify this before I take the derivative. You can think of the 2 over 1 if you want. So when I simplify that, it's going to turn into x plus, if I take 72 times 2, that'll be 144 over x, and it still equals a minimum. Okay, I need to take the derivative. Now, derivative of x is just 1, so that's probably the easy part. Derivative of this is going to take a little bit of work, so I may actually come over here to look at the derivative of that second term. What would be another way to write 144 over x? Very good. 144, x to the negative first. That's not the derivative. That's just me rewriting it. And so now, pull the exponent out front, make it to the 1 less power. And I don't like to leave a negative exponent in my derivative. So I'll rewrite that as negative 144 over x squared. Now when I put that back in, I may just do this. I'll take 1 minus 144 over x squared. And again, I don't know what the min is, but I know it's just a number, and derivative of any number is just 0. Okay, to solve this for x, what I would do first is basically add this term to the other side. That way I don't have to worry about that negative sign anymore. So right now it says 1 equals 144 over x squared. Now I'll go ahead and multiply by x squared on both sides. That's just me trying to get rid of it right there. And when I go to square root, remember we only want positive numbers, so you don't have to worry about the plus or minus. It's just going to be 12. So right now, one of my answers is 12, And the easiest way to find y is to probably just plug your x back in right here where you had y by itself. So if you take 72 divided by 12, that should leave you with a positive 6. So the two numbers whose product is 72 and whose sum of the first plus 2 times the second is a min, those two numbers would be 12 and 6. Okie doke. Any questions about that one? All right, nice part about these is that a lot of them work the same way, especially the setup. Once you kind of understand how to set up the primary and the secondary, a lot of them tend to work out the same way. All right, example 3, this is our last one. Find the length and width of a rectangle. Find the length and width of a rectangle whose perimeter is a minimum. I haven't talked about perimeter in a while. Whose perimeter is a minimum and whose area is 100 inches squared. Find the length and width of a rectangle whose perimeter is a minimum and whose area is 100 inches squared. You really don't have to draw a picture of a rectangle here, but as far as the length and the width, I usually call the longer side the length, the other side the width. So you can actually set this up 2 different ways and it will not matter either way. You'll get the same answer. But I'm going to call the length here x and the width y. Let me write that out for you. Let x equal the length and y is going to equal the width. I didn't have to do it in that order. I could have said let y equal the length and x equal the width. Work would look different, but you would end up getting back the same answers. All right, primary should be the part of the problem that talks about the minimum or the maximum. It's minimum in this case. So right here, and actually I may put my picture back up just so we can think about perimeter for a second. But right here is talking about a minimum. The perimeter is a minimum. You can just take, I mean, if this is x, that's x, and if that's y, that's y. If you want to just take x plus y, that's fine. Maybe a more condensed version of that would be 2x plus 2y. I'm going to go ahead and do it like that so it looks like it's simplified. But that perimeter is going to be a minimum. Area of a rectangle, that's going to be my secondary equation. How do we find the area of a rectangle? Length times width. So x times y, that is going to be 100. I'll worry about putting my units back up once I'm done with the problem. So I always like to solve it for y. If you have a problem in your homework where it's a little bit easier to solve for x instead, then by all means do it that way. It doesn't matter which variable you solve for. Okay, plugging that in for y, now it says 2x plus 2 times 100 over x equals a min. And this is actually very similar to how we had to solve the last one. When you take 2 times 100 over x, that's just going to be 200 over x. Derivative of 2x is 2. That's not too bad. But here we go again. 200 over x is the same as 200x to the negative first. So I'm taking the derivative the very same way I did it on the last problem. It's going to end up being a negative 200 over x squared. And I don't know what the min is, but I know it's going to be a constant. So derivative of any constant is 0. All right, I'm going to add that term to the other side. Then I'm going to multiply by x squared, so it's not on bottom anymore. And let me erase this over here so I've got more room. Now it says 2x squared equals 200. You'll have to divide by 2 first before you square root. Now when I square root both sides, I don't need the plus or minus here either because we're talking about the length and width of a rectangle. You don't want those to be negative. So the length is going to be 10 inches. And the width here, if you plug that back in to find y, 100 divided by 10 is another 10. You will notice in the homework that a lot of times you do end up with the same numbers, but it won't be like that every time. Okie doke. Any questions on that? Okay, we only have about a minute left here, not a whole lot of homework time. So this is C65 from page 262. We're going to try 4 to 9 and then number 11. 4 to 9, number 11. I will tell you on number 4, you might get back some decimals. You can leave it as a square root or use decimals, either way. And it might happen again on number 8. So 4 and 8, expect decimals.